Welcome back. Let's start section 3.8, derivative of inverse functions and logarithms. Okay, so to start with, I will use the first part to introduce a little bit background about function and its inverse function. Okay, some of you might still remember, and some of you might already forgot. And then this is a wrap up. Okay, about. Okay, so first of all, about notation here, given a function f of x, and the notation of the inverse function, which is written into this way, which is called f inverse. It's not a power, okay? And also, second, how do we know that whether a function has an inverse function or not? Well, there's a criteria or condition. So only when the function is a one-to-one function, then it has an inverse. So what does that mean about the one-to-one function? Well, for example, guys, let's first of all draw those two graphs, okay? So f of x equals 2x plus 1 here, which gonna be something like this, okay? It's a straight line here. And for this one, fx equals x squared, it's a problem, okay? Something like this. I'm not very good at drawing, but you got it, okay? So first of all, guys, remember that when we talk about how do we decide whether a graph stands for a function or not, we use the vertical line test, right? So draw a vertical line, so the intersection, and most you have one intersection. Apparently those two satisfy the vertical line. And the second thing is, so how do we know a function is a one-to-one function? Well, the meaning of a one-to-one function, it says like this. So when you have an input x, the corresponding f of x in the range, there is exactly one correspondence for the input x. So that's the definition for the function. One input must correspond to one output, okay? However, the one-to-one means like this. Every member in the range or the output only have one exact input. So that's what we call the one-to-one. For example, like for this example, f equals x squared. We know that f of 1 equals 1 squared equals 1, right? And f of negative 1 equals negative 1 squared is also equals 1. So you see that this the input of 1 and negative 1, they both map to the output of 1 here. So in this way, this is not a one-to-one. So, but how do we check that if you know the graph? Well, the method or the shortcut here is if you know the graph, we can use the horizontal line test. Okay, so you see that I draw two horizontal lines. And if you have at most one intersection point with the graph, then the function is a one-to-one function and it has inverse. Okay, for example, like this, as you can see that it has two intersection points, right? So f of x squared is not a one-to-one function, hence it does not have an inverse. Okay. However, for fx equals 2x plus 1, well, it does has an inverse function. Okay. Okay. So that's the first part. And then, very briefly, let's talk about this. How do you find an inverse function? Okay. If I know that the function is a one-to-one function, and hence it does have an inverse, but how to figure it out? Well, I would see the basic steps, okay, for solving inverse function is very straightforward. Okay, for example, like this. Fx equals 2x plus 7. What you do here is, first of all, you replace your f of x with y, okay? So you can have this y equals 2x plus 7, okay? And then, what you do here is interchange x and y. And then, so y becomes x, x becomes y. So you have x equals 2y plus 7. So this is step 2. Step 3, solve y in terms of x. So you can get x minus 7 over 2 equals y, and replace that y with f inverse. So that's it. That is exactly f inverse, okay? Also, guys, what does that mean about the f inverse? Maybe we can also think about this problem here. So you see the given function structure is like this. So when I have an input, the rule for this function is double what you give to me, right? 2 times of x and then add 7 there, okay? So right, double it and then plus 7. But let's also look at the inverse. What do you have give to me? Subtract 7 and then divide it by 2. Do you see that? Do you see this is kind of like the way to move forward? Double what you have plus 7, but this is kind of like going backward. Do you see that? Subtract 7, right? Because you add a 7 there, and then half it because you double it. Okay, so you can see. Also, there are some properties about the inverse function here. So for here, fx and it's f inverse. Okay, so the domain and the range. So you will see that, guys, the domain of the original function, it becomes the range of the inverse function, okay? And the range of the original function, it becomes the domain of that function, okay? And also, so this is the domain and range, they interchange because x and y interchanged, okay, as you can tell. Also, the graph of the function, so the fx and f inverse, they are symmetric with respect to y equals x, okay, y equals x. And you see a very classical problem. We already know that this is the natural exponential function, right? Okay? And this is the natural logarithm. So as you can see that the graph actually, it is symmetric with the dashed line y equals x, okay? So this is the first part about the inverse function, okay? It's kind of like a little background. In the second part, what we'll do here is we're going to talk about, okay, how do I figure out the derivative of an inverse function evaluated at a specific point? Okay, so I'll see you in the next video.